Hey guys, welcome to the channel, and today we're discussing about the correlations and covariance. What does it mean correlation and covariance, right? So correlation, let's start with the definition and understand what is a correlation and covariance. So first, covariance and correlation are two statistical measures used to determine the relationship between two variables. Both are used to understand how change in one variable are associated with the change in another variable. That's your correlation covariable, right? So how to look like the segments? So if any independent feature are the change, then how to change on a dependent feature? That is your that's the relationship between the independent feature and dependent feature. That's what we are find out using the correlation and covariance. That's called the correlation, right, and covariance. So first we understand what is a covariance. Covariance is a measure of two random variables changed together. If the variable tend to inverse and decreases together, the covariance is positive, right? The covariance is positive. If tend to increase when the another decreases, the covariance is negative. That is just so simple of covariance and correlations between that. So we first that is help us to understand that small thing is with examples, right? So we are starting the examples. So we have data points just like if says that we have x and y axis, right? We have x and y axis. So we are starting with the data points like 2, 4, 6 and 8, and 3, 5, 7 and 9, that we have data points, right? So understand that thing. So if the let's find out the quantifying the relationship between x and y axis. So we are find out the relationship between x and y axis. This is the covariance. Okay, see the in four parameters are there for the correlations and covariance, and that is if the x axis are increases or y axis are also increases in right. In that case, if the independent feature are increases, just like in house of the if you says okay, that's understand. We starting with that. So we are another get another example, that is the size of house right? That's we are starting the size of house and price of the house. Price of house. So if the size of house is 12 square feet, then is the price become a 45 lakh, right? And size become 300 square feet, its spend is a 50 lakh. And if size is the 1500 square feet, its mean is let's consider 60 lakh, right? This is your extent. In that case, if x axis are increases, then y axis also y it's mean a dependent feature also increases. In that case, in another reason, if x axis are increases, then y axis are decreases. In another, if sometimes happening, if the one axis if independent feature are increases but dependent features are decreases, that is a relationship between scenario and quantifying the scenario, right? And then another segment is if the x axis are decreases, then y axis are increases, and both are decreases. In another case, x axis all decreases, so y axis also decreases. That is a four relationship. There are four relationship in between the, that's quantifying the relationship. We are see and understand how to look like a graph and how the data points were plotted in a different way. If that that relationship are happen, right? So we start with the box plots, and then understanding the what is find out the relationship between the x-axis and y-axis, find out the formula as well. First we plotting a box, plotting a graph. So how look like your uh, how to look like a data, how to distribute data in that form. So first we start with a uh, if the x-axis are increases and y-axis are increases, and x-axis are decreases and y-axis also decreases. So that's a blocks plot, and data point are distributed in that form. Okay, that your data form are distributed. This is called nothing but it's a positive covariance. That is nothing but positive covariance. Just look at that graph, and if the x-axis increases, it means independent feature increases and dependent feature increases, right? If the independent feature decreases, also simultaneously dependent feature also decreases. The plot look like a just like that. That's called nothing but is your positive covariance, right? Simultaneously we are going to another case. If x-axis are increases, then y-axis are decreases, and then x-axis are decreases and the y-axis also increases. In that case our graph look like a that your data points are distributed in that way. That's nothing but it's a negative covariance. That is nothing but negative covariance. That's your graph distribution, and that is your how to correlation between x-axis and y-axis, and how to look like the positive covariance and negative covariance. That understand the definition. The definition says that the correlation is a measure of two random variables you say x-axis and y-axis change together if the variable tend to increases and decreases together, right? In that case, that is a covariance is a positive. That's a positive covariance, right? X-axis are increases and y-axis are increases. X-axis are decreases, then simultaneously y-axis are decreases. That's a positive covariance. If the one tend to increases when the another tends to decreases, and covariance is negative, and that's its form is a negative covariance, right? So for then we are going with the next segment. We are going with the next is a covariance formula. How to find out the covariance, right? Covariance is the formula, right? So if talking about the covariance formula, says the covariance of x-axis, covariance of x and y-axis is nothing but summation of I to 1 to n is I minus x minus x bar into y1 yi minus y bar divided by n minus 1, right? So understanding what is it, x1 is nothing but data point of x variable, x1 is nothing xi nothing but data point of x variable. What is a y bar is nothing but mean of x, right? And what is a y is y nothing but data point of y variable. What is a y bar is nothing but is a mean of y, right? And what is a n is a number of data point. Is n, if talking about n, is a number of data point. Is mean n is nothing but is a number of data point. And this is a formula to calculate. And this is a formula to calculate the covariance formula, right? Nothing but is a covariance formula. Let's we start with example and understand how the things are work. Okay, and find out the formula. Let's get a student. We start with the example of study hours. Study and exam score. It's in second is the exam score, right? And this is your data. This is a 2, 3, 4, 5, 6. That's any student in different student study hours, 2 hours, 3, 4, 5, and 6. And exam score is nothing but 50, 60, 70, 80, and 90. That's a graph look like. So we are find out the covariance is positive or negative. In that case, okay, we start with the formula. Is this is a formula. The first we are this is our formula. First find out the mean of x. Mean of x nothing but summation of 2 plus 3 plus 4 plus 5 plus 6 divided by 5 is 4, right? And mean of y is nothing but 50 plus 60 plus 70 plus 80 plus 90 divided by 5 is nothing but 70, right? So calculate the covariance. If the calculate the covariance of x and y is nothing but summation is nothing but like this is a formula and we are summing the thing. So how your how the look like that summation of x1 is a, okay, 2 minus 4 into y1 50 minus 70, x2 is a plus 3 minus 4 into 60 minus 70 plus 4 minus 4 divided by 70 minus 70 plus 5 minus 4 into 80 minus 70 plus 6 minus 4 into 90 minus 70 divided by 5 minus 1. And its final answer is 20. Final answer is 20, right? So this is a positive covariance. This is a positive covariance, right? This is your positive. This is your positive covariance, and this will look like this is your positive covariance, and that's your look like a, if you are plotting a graph, then is a graph where a graph look like that type of graph or a bead, because this is a positive covariance I am seeing in a previous video, right? So we are again let's say one example of negative covariance. You try to solve this negative covariance. So it's a negative covariance, negative covariance. So for negative covariance, then you solve this problem. X 7, 6, 5, y is equal to 10, 10, 12, and 40. In that case, x axis are increases, y are decreases, or x decreases and y are increases. That correlations are that is correlation between x axis and y axis, if see, right? So if talking about the correlations, okay, we see the covariance, and then another we start with the correlations. This is a correlations, right? So if talking about the correlations, there are two types of correlations in x axis and y axis. This is the Pearson correlation, Pearson correlation, and second one is Spearman correlation. Spearman correlation, right? There are correlation. We see covariance. Now see the correlations of between the x-axis and y-axis. So talking about the formula. First, Pearson correlation is vary -1 to 1, right? And this formula is x and y is nothing but covariance of x and y divided by x dot y. This is your Pearson correlations formula, right? And see the Spearman rank correlation. Second one is you look like the formula, right? This is Spearman correlation. Let me see the Spearman rank correlation. Spearman rank correlation. Spearman rank correlation. And talking about the formula is y is nothing but covariance of rank minus y divided by rank x. This is a formula of Spearman rank correlation, right? So this is our video and that's done today.